Do you have basic web development skills and want to turn these skills into building cross-platform desktop applications for Linux, Windows, and macOS? With Electron, it's possible, and I'm happy to offer you this complete Electron course totally for free. Electron is widely used now by big tech companies, and it's gaining very high popularity, and it's used to create very popular applications like Visual Studio Code and Slack. So it's a very valuable skill to learn and will make you stand out in the market. In this course, you will learn everything you need to start working with Electron and developing cross-platform desktop applications by practically learning all Electron concepts through working on an application, starting from creating this application from scratch until building and packaging the application and making it ready for production. I hope you're excited about completing this course, and enough with the talking, let's start. Alright, so let's start with understanding what exactly is Electron. Electron is a framework for building desktop applications using HTML, JavaScript, and CSS. It uses Chromium, which is an open source browser that's used by Google Chrome. And for the system-related APIs, it uses Node.js. So to understand how Electron applications work, let's see an example. Imagine you have a website, and this website is opened in a browser. So the browser will render the front end of the website, which is a bundle of HTML, CSS, and JavaScript files. And the front end will communicate with the server using REST API. And let's consider that the backend framework used in this website is Node.js. And these are the main components of the website. Now let's see what is an Electron application composed of. So since the front end of the application or the UI of the application is developed using HTML, CSS, and JavaScript, Electron uses Chromium to render this front end. But since Electron applications run on operating systems like Windows, macOS, or Linux, so it needs to do some system operations as well, like to operate or handle files or call some system APIs and so on. And this is not available from HTML and JavaScript. So, like Electron applications need also a backend server, right? In this case, the backend server is actually the device on which the application is executing. And the backend framework used is Node.js. So we have two parts, the front end part, which is HTML, JavaScript, and CSS, and the back end part, which is the process that runs on the user device. In this case, the user device is the server, and this process has access to all the system APIs, and it's executed using Node.js. So now you might wonder, in typical websites, the communication between the front end and the back end happens using REST APIs. So in Electron applications, how the communication happens between the front end and the back end? Basically, it happens using a module called IPC, or inter-process communication. And we are going to learn more about this later in the course. So basically, that's the main components of any Electron application, and that's how it works. And I made this analogy just to make it simpler for you to understand by comparing it to a website, because you are most probably a web developer, so making this analogy will make it easier for you to understand. The front end part in Electron is called the renderer process, and the back end part, which is executed by Node.js, is called the main process. So this process has access to all Node.js APIs and all the operating system APIs, and both are separate processes. And as we learned, they communicate through IPC, or inter-process communication. So now, what is the advantage of using Electron? The advantage of using Electron is to develop native applications that is cross-platform. So you have only one code base for the application, and you can build this project into multiple operating systems like Windows, macOS, or Linux. And this, of course, saves much time and effort. And also, to develop native applications, you don't need to have native development knowledge or skills, because with Electron you can just use JavaScript and HTML and CSS. So if you are already familiar with web development, then you can start right away developing native applications using Electron. Alright, let's start setting the environment. So for this course, I'm going to use Visual Studio Code as an IDE, but feel free to use any other IDE or text editor that you prefer. Alright, so to download Visual Studio Code, you can go to code.visualstudio.com, and I'm using Windows, so I'm going to download for Windows. And after the download is finished, you can start the installation process, and then we are ready to start coding with Visual Studio Code. So that's it for the IDE. We would also need to use Node.js, so you can go to nodejs.org and download Node.js. So I'm going to click here and download it, and also follow the installation process. It's a typical installation process. And once the installation is finished, go to the command line either in Windows or Linux or Mac OS, then type the command node, then space, then -v to make sure that node is installed correctly. So if I hit enter, I can see the version of the installed Node.js. If you see the version of Node.js, that means Node is installed successfully. Otherwise, it means there's an issue. So that's it for the environment setup. It's a very simple and easy environment setup. And if you face any issues or you have any questions, feel free to write a comment on the video. All right, let's start creating our Electron project. So first, let's go to the command line and create a new folder for the project. Let's call it screen-capturer. Then let's go to the folder, and here we want to initialize an npm project because Electron is actually an npm package. So to be able to use it, we have to install it in an npm project. So to create an npm project, we have to use the command npm init. So this will initialize an npm project in the current directory. So as you can see, Node will ask you some questions about this package. For example, the package name, let's keep it to the default value, which is the name of the folder. Then the version, let's also keep it to the default value. Then the description, let's type a screen capturing app using Electron. Then the entry point. So this is the entry point of the application. We're gonna call this file main.js. Then let's keep the test command empty and the Git repository also empty, the keywords empty. The author, you can type your name, for example. I'm gonna just keep it empty as well. And the license, let's keep it to the default value. And that's it. So now we see an overview of all the options we configured for this npm project. So let's just type yes and hit enter to confirm these options. And now we created or initialized our npm project. So let's see the contents of this folder. Let's type ls and hit enter. As you can see, now we have this package.json file, all right? So this file is actually the configuration file for the npm project, but we still don't have any files yet, right? So we are going to create all the files from scratch for our Electron application. So first, let's open this folder in our IDE. So since I'm using Visual Studio Code, I'm gonna type in the command line code, then space, then dot. This will open the current folder in Visual Studio Code. But if you are using any IDE or any other IDE or any other text editor, you can just open the folder in the IDE, or if you are using Visual Studio Code, you can use the same command. Alright, so I opened now the folder, and as you can see, this is the content of the package.json file. Alright, so this is the configuration that we configured for our npm project. Now we want to install Electron, right? So as I told you, Electron is an npm dependency. So we want to install it in our current npm project. To do that, we go back to the command line and type npm install, then /save-dev. That means install this dependency as a development dependency because we want to use Electron only during development. So then we type Electron, which is the name of the dependency, and hit enter. So now the package is installing. Alright, so after it's installed, let's go back and see the package.json. We can see now this dev dependencies object added, and inside it there is the Electron package with its version. Alright, so that means now Electron is installed successfully. To be able to start the Electron application, we have to add another npm script here. So let's go to the scripts object and add another entry. The key is the name of the script, which is start, and the value is the command that will be executed, which is Electron space dot. That means start Electron in the current directory. Okay, so now let's go and try this script. Let's go to the command line and type npm, then the script name, which is start. And now as you can see, the project is starting, but there's an error because there is no entry file for this project, right? We configured the entry point of the project to be main.js, but this file doesn't exist. So we have to create this file, all right? So let's go back to Visual Studio Code and create it. All right, so now we created the main.js file, and basically this file will represent the main process in our Electron application, okay? So this is the process that will be executed by Node.js, and it has access to Node APIs and all the system APIs. And it also has access to Electron APIs, okay? So we are going to use this process to create our application window, okay? How to do that? We have to import some modules from Electron first. So I'm gonna type here constant, and then between two curly braces, the modules I'm gonna import from Electron, which are app and browser window. So app is a module that represents the current Electron app, and the browser window is a class that allows us to create application windows, okay? So any native application window we create in Electron, we use the browser window class to do that. And now I'm gonna assign this to required Electron, okay? So now we imported these modules from Electron. What is the next step? We want to check if the application is ready and initialized. If that's the case, then we want to create the application window or display the application window. So how do we know if the application is ready and initialized by Electron? We can use a function called whenReady from the app module. This function returns a promise that will resolve only when the application is ready and initialized, okay? So we can use then here to resolve that promise and pass a callback function that will be executed when the promise is resolved. And then here we want to write the code that will create the new application window. So let's create a constant, call it window. We will store the window instance here in this constant and assign it to a new instance from the browser window. So that's all what we need to do to create a new application window in Electron. Just create a new instance from the browser window class. Now let's go to the command line and start the project. And here we go. So you can see now the application window is started and displayed. But of course it doesn't have any content yet. Why? Because as we understand that Electron uses Chromium to render the UI of the application. Okay, so far we did the main process part, which is responsible for creating the window, but we have to implement the renderer process part, which we learned about in the beginning of the course. The renderer process is responsible for rendering the HTML, CSS, and JavaScript files of the front end or the UI of the application. So we didn't add any HTML or JavaScript or CSS files yet. Okay, so this is the time to do that now, to display the UI of the application. So let's start with the HTML file. Okay, so I'm gonna create a new file called index.html. Then in the file, I'm gonna start creating the boilerplate code for the HTML file. So HTML tag, then head tag, then title tag to set the title of the application, then the body tag. Okay, then let's add a span to display the project or the application name. Okay, so let's type here screen capture. Alright, so now we created the HTML that we will render in our application. But how do we tell Electron to load this file or to set this as the UI for the window that we created? So we have to go to the main.js again, and from our window or from our browser window instance here, we stored in the constant window, we have to call a function called load file and pass the HTML file path that we want to load in this window. In this case, index.html. Alright, so now that's it. Let's go back to the command line and run the application. And here we go. So now we can see the span displayed, and we can see also the title of the application has been set to screen capture. So we loaded the HTML now in our application. So now we also would need to add some CSS code to this application to style it. So let's create a file called styles.css, and then let's go back to index.html and include this file here using the link tag. Okay, so I'm gonna set the href attribute to styles.css in the current directory and the rel attribute to style sheet. Now we loaded this CSS file in our index.html. So let's add some styling just to test the application. Alright, so I'm gonna just change the background of the body to blue. Okay, now if we start the application, we can see that the background has changed. Alright, so each time we do a change in our code, so for example, if we remove the background color, okay, we have to restart the application, right? And we have to go to the command line, close the application, and start it again. And this might consume some time, so we can avoid this by installing an external dependency called nodemon. Alright, so this is a package that will monitor all the files of the project. If any of the files change, then it will reload the application and restart the application automatically. So we don't have to do it manually. So to install this external dependency, we can basically do the same thing as we did with Electron. So npm install and also --save the -dev, because this is development dependency. Then the name of the dependency, which is nodemon. Okay, then that's it. Hit enter, and after it's installed, you can go back to package.json. You will see it in the dev dependencies here as well. So we have to modify our start script to use nodemon instead of Electron. Okay, so let's type nodemon, then space, then _x. So this means watch for these extensions for these file extensions. So we want to watch JS, CSS, and HTML extensions. If any code changes happen to these files, then we reload the application. Okay, let's type _exec, or this is an abbreviation for execute. Alright, so that means execute this command when a code change happens in files with these extensions. Okay, so the command that we want to execute is Electron. Okay, so Electron space dot, that's the command to start Electron. Alright, so now if we go back to the command line and type npm start, as you can see now nodemon started this application. And now if we go and make any change to any of the files with extension CSS, HTML, or JavaScript, so for example, let's set the background color again to any color, blue for example, and if we save the file, you can see that the application was restarted automatically. Okay, of course this is very useful during development to see our code changes directly without having to do this manually. All right, so now let's continue with creating the UI of the application. So let's go back and let's go to the HTML code and add here a div and set its class to navbar and add the span in this div. So this is gonna be a navigation bar for our application. All right, we're gonna remove the default navigation bar and use this as a navigation bar. All right, so let's also create a new folder and call it assets. We are going to add our images here. Alright, so since we are developing a screen capturing application, so this application will allow us to click on a button and capture the current screen, alright, as a screenshot, and save this to a file. Alright, so it will save the screenshot to an image file. So we would need a button, alright, to be able to click on it and capture the screen. I'm going to use this camera image as a button, so you can download this from the link in the description of the video, okay, and add it to the assets folder in the project like that. Alright, so now let's go back to the HTML code and let's add another div and name it container. Alright, and we are going to add the button inside this div. So let's add an image. This will represent the button. Actually, it's an image, not a button, but we are going to use it as a button. Okay, and let's set the source to the path of the camera.png file. And now, as you can see, this is how it looks like. So we want to reduce the size of it and also center it in the middle of the window. All right, so to do that, let's do some styling of the application. Let's go back to styles.css, and for the body, let's set its width to 100 VW. So that means 100% of the current screen. All right, and the height also to 100 VH. That means 100% of the current screen height. Okay, so now we make this application, or we make this window consuming the full screen size. All right, now let's style the class of the nav bar. Okay, so this is the navigation bar. We want its height to be 50 pixels, and let's set its background to gray, and the color, the font color, to white, and the width to 100% to make it 100% of the screen width, and the position absolute because we want to keep it always on the top. Right, so let's set the top to 0 and also to the leftmost of the screen, so let's set the left attribute to 0. Let's set the display to flex, right, because we want to align or center vertically the title in this navbar. So let's use align items to center. Let's set align item to center to do that. And let's also give it some padding, some left padding. So let's set the padding left to 10 pixels and the font size to 20 pixels. And that's it. So now if we save, you can see that this is how the navbar looks like now. But we want now to remove the default navbar and also the default menu that is created by Electron. To do that, we can configure the browser window instance that we created using an options object that we can pass to the constructor. This is an optional argument, so that's why we didn't pass it, and this is fine. But if we want to configure the window, we can pass it. Okay. So if we click on Alt and click on the class here to see its constructor, and we can see this options argument. All right, so if we also click on Alt and go to the definition of this browser window constructor options, you can see here that it extends another class. So let's click on Alt and click on it, and you can see all the configuration options that we can configure here. So one of them is the frame option, which is a boolean, and this is by default is true. Okay, if we set it to false, we will create a frameless window, and that's what we want. So let's set this frame option to false. So let's go back to main.js and pass this options object here to the browser window constructor and set frame to false. If we save, now you can see that the frame is not there anymore. Alright, but now we cannot drag the window anymore, right? Because we used the default frame of the window previously, or the default nav bar, to drag the window. Now we can't drag it anymore. But we have our custom nav bar and we can use it to drag the window. So we have to set an CSS attribute to do that. Let's go back to the styles.css file and add this CSS attribute. So dash webkit dash app dash region, right? Then column, okay, then drag. So that means any item with this class will be able to drag the window. In this case, the navbar only, alright, will be able to drag the window. If we go back now to the application and drag the window using this navbar, you can see that it drags the window normally. So now let's also make our window transparent, just to make only the camera button visible and the navbar. Alright, so let's go back to the browser window constructor and pass a transparent attribute and set it to false, set it to true, excuse me. This will make the window transparent, as you can see. But we still see this scroll bars. This is a very common issue in Electron. We can remove this using CSS as well as a workaround. So we can set the overflow to hidden for the body tag, okay? So let's go to styles.css and set the overflow attribute to hidden. And now if we save, you can see that this is how it looks like now. So now what's remaining is to center this camera button in the center of the window and also make it smaller. So first let's go to index.html and let's set a class to this image, camera-image. Then let's go back to styles.css and let's style this class, alright? So let's set its width to 120 pixels and let's set its height to also 120 pixels. And let's set the cursor to pointer to make the cursor pointer when we hover over it. And also we are going to use an animation to make it a bit larger when we hover over it. So we don't want this animation to be instant. We want it to be a transition animation. So we can set the transition attribute to transform and set the time to 0.2 seconds. So that means this animation will happen on 0.2 seconds, okay? Or during 0.2 seconds. So now let's add this animation actually. So we want to do this for the hover event when we hover over the camera. So let's add here the transform to scale and pass here 1.1. That means make this image 1.1% larger than itself, or 110%, right? In other words, larger than its actual size. So now if we go to the application and hover over it, you can see that its size increases a little bit when we hover over it and then goes back to normal when we hover away from it. Alright, so now let's center this camera in the middle of the screen. So to do that, we can style the container div in which this image exists, and we can set the display to flex, and then we can use a justify content to center. This will center the image horizontally in the div, and we also want to center it vertically. So we use align items and we set it to center it vertically. And then we set the height of this div to 100% to make it also consuming the full size of the window. And here we go. So now the camera button is centered. All right. So that's it for the UI of the application. All right. So now we are done with the render process. All right. And also the main process. All right, because we implemented the UI of the application and main.js, all right, which is representing the main process in our application. So now the remaining part is the communication between those two processes. Okay, so whenever we click on the camera button, all right, we want to capture the screen and save it to a file. But as we learned from the render, we cannot do this because we don't have access to the system APIs or any Electron or Node APIs. So what we want to do is we want to send a message to the main process to tell it that we want to do this. All right. So as we learned, this communication happens through IPC. But first we have to have some JavaScript code in the renderer to be able to handle the click on this camera button and then send the message to the main process. So let's create a file, a JavaScript file, and name it renderer.js. So this is gonna represent the renderer process, okay, the JavaScript code of the renderer process. And now let's add a script tag here in the index.html to load this script. All right, so let's set the source to the path of the file, which is the current directory, then renderer.js. And now let's go to renderer.js and import some modules. So we are going to import a module called IPC render from Electron. This module will allow the render process to use IPC to communicate with the main process, okay? So as you can see, when we imported this module, there is an error that says require is not defined, because by default, Node is not allowed for the render process, and the renderer cannot use Node APIs, as we learned, okay? So sometimes during development, it's okay to enable Node, all right, for the render, to make Node available for the render, but that's not recommended for production, okay? But for now, let's just enable Node for the render. We can configure this from the options object that we pass to the browser window constructor. So we pass an object called web preferences, okay? And in this object, we set the context isolation to false and Node integration to true. So that means we enable Node for the render, all right? And now the render can use Node.js syntax, okay? So if we go back now, we don't see that error anymore. All right, so now we imported the IPC render module from Electron in the renderer. And now we can use it to communicate with the main process and send a message to it, okay? But before that, let's just make sure that the renderer is working properly. And let's just display an alert, all right? And say hello from the renderer and see if this will be executed successfully. So let's save now. And as you can see, the alert is displayed. So that means the renderer is working as expected, okay? So now we can send a message from the renderer to the main process using the IPC render.send, so the send function. And the first argument of this function is the channel. So this is the name of the message, in other words, all right? So we can name it capture-screen, okay? So now we send this message to the main process from the render process. But we don't just want to send it anytime like this. We want to send it only when we click on the image button. So first, let's set an ID to this image button. Okay, let's call it camera-button. And let's listen to the click event here using document.getElement by ID first to get this element. And then we use add event listener to add an event listener on the click event. So the first argument is the string click, which is the event name. And then the second argument is a callback which will be executed when this event is triggered. So in this case, we copy that line or cut that line and paste it here to send the message. All right, so now we send the message, but we want to listen, or we want to handle this message from the main process. So let's go to the main process and import a module called IPC main. So this will allow the main process to use IPC to send messages from the main process to the render process, or to handle messages sent from the render process to the main process, okay? In this case, we want to handle a message. We can use IPC main.on, all right? That means on, or when this message is received, do something. So the first argument is the message name, okay? So in this case, capture-screen. And the second argument is a callback function, all right, that will be executed or invoked when this message is received. All right, so for now, just for testing, let's log something on the console. Let's say handling capture screen. And let's go back and click on the camera button to test this, right? And as you can see, there is an error, cannot read properties of null, okay? The reason is we are trying to get an element by ID, and we loaded the script before actually creating that element, all right? So our workaround for this is just adding the script tag after that element, all right? So at the end of the body tag here, okay? So now if we save that and go back and click on the camera button, we will be able to see the message here logged on the console. So now that means the communication between the main process and the render process is done or happening as expected, all right? So now let's do the actual implementation, which is capturing the current screen and saving it to a file. So let's delete that console.log line. We don't want it anymore. And to be able to capture the screen, we need to import two modules from Electron. The first one is screen. So this will provide some information about the current screen, okay? and desktop capture, which will capture the current screen. Okay, so after importing these, let's start the implementation. So the first step is getting the current screen size. So let's create a constant, call it screen size, and use screen.getPrimaryDisplay, okay, to get the current primary display for or the current primary screen, okay, and use the attribute work area size. So this will retrieve the size of the current primary display. Okay, all right. So the second step is to retrieve the thumbnails, all right, or the images of the current screens. Okay, we can do this using the desktop capture module. So let's create a constant, let's call it screens, okay, and assign it to this. First we type the await keyword because this is an asynchronous function, and the function is desktop capture dot get sources. So this function will resolve a promise with an array of desktop capture source objects. So each of them represents a screen, okay. So we have to pass an options object to this function, okay, and this object has an attribute called types, all right, which is a list of the types of sources we want to retrieve. So we want to retrieve screens, right? So we type here only one item, which is a string, which is a screen. And we can also set the thumbnail size. So this is the screenshot size, right? So we have already the screen size. We retrieved it and stored it in the constant screen size. So we can set the width of the thumbnail size to screen size.width and height to screen size.height. Okay, so now we configured the desktop capture and we retrieved the current screens, all right, and store them in this constant, all right. And we also configured the thumbnail size. That means that we configured the screenshot size, and now this screens list has all the current connected screens. So in this list, the primary screen is always the first one. So we can retrieve it from the screens array using the index 0, okay? Then if we want to retrieve the image or the screenshot for this screen, we use the attribute thumbnail, okay? And we store this into the image constant. But first we have to convert it to PNG, all right? To convert it to a PNG image. So we have now this image data here stored in this constant. So the next step is actually saving it to a file. We are going to use the current timestamp to make the file name unique, okay? So let's create a constant, call it timestamp, and assign it to a new date instance, then call to isostring to convert it into a string. And then let's also use this replace function to replace any dots in the file with dashes, because we cannot have dots in the file name, okay? Because dot is used for the extension of the file. So we have now the timestamp, and we want also to append or prepend something to the file name, so like a screenshot, for example. All right, so let's create another constant, assign it to screenshot, then dash, then the timestamp, then we append the timestamp. All right, then the extension, which is .png. So now we have the complete file name. So the remaining part is having the complete file path, okay? So we are going to use the path module from Node, okay, to be able to create a path that's compatible for any operating system, okay? So whether Linux, Windows, or Mac OS. So after importing path, let's use path.join, okay, and join current directory. So we can use the current directory in the code using __ their name, okay, and we join this with the file name. So now we have the complete file path, which is the current directory followed by the file name, okay? So the remaining part is actually creating that file and storing the image data in it. So we use the fs module from Node to create files and write to files. So let's import it, and let's use the write function from the fs module to write to this file. So the first argument is the file path, okay, so let's pass it, and then the second argument is the data of the file, so let's pass image. Then the third argument is a callback function that will be triggered after writing to this file. So it takes one argument, which is error, in case if there is any error with writing to the file. So what we care about is that this function will be called after writing to the file, and we want to actually open this image using the default image opener in the operating system, okay? So to do that, we use another module from Electron called shell. So make sure to import it as well, and then we use the open external function from that module to open a file using its default application configured for opening this extension in the operating system. Okay, then we pass the complete URL of this file. So in this case, file, then column, // then the file path. Okay, that's it. So after the file is created and the data is written to it, we are going to open the image using the default image opener in the operating system. Let's save and let's try the application now. So if we click on the camera button, you can see that the screenshot is taken and also saved to a file, and the file was opened by the default file opener. All right, so now everything is working as expected. You can see now the screenshot file is saved to the current directory, as you can see. All right, so now let's create a tray icon for our application so that when it starts, it actually shows up as a tray icon in the operating system. And then we can toggle the application using this icon. So we can click on it to display the application and click on it again to hide the application. All right, so how do we create a tray icon in Electron? The first step is actually creating the same icon we are using so far, so the camera icon. All right, let's just create a constant and assign it to the path of this icon. So I'm gonna use path.join, then _, their name for retrieving the current directory, and join this with assets, then / camera.ico. So this is the full path of the icon. After that, we need to import another module from Electron called tray. Okay, so this is a class that will allow us to create a tray icon for the application. And all what we need to do is creating a new instance from this tray class. So let's do that and store this instance in a constant called tray, and we pass an argument to this constructor, which is the path of the icon. Okay, that's it. So now we created the tray for the application, and if we save, we can see the tray icon, as you can see here, of the application with the icon we set. The point is, when we create a tray icon for the application, we don't want to display the application by default. All right, we just want to display the tray icon, and when the user clicks on this icon, the application is displayed. So we can hide the window of the application by default when the application starts. This is an option or an attribute that we can pass to the options object we pass to the browser window constructor, which is show. By default, it's true. That means show the window when the application starts. We can set it to false to disable showing the window, okay? Because we are gonna show it programmatically. Now we don't see the application, and when we click on the icon, we also don't see it. We have to handle the click event on the icon and show the application. So how do we handle the event, the click event on the icon? We can use tray.on, okay? So the on function from the tray object, and this takes two arguments. The first argument is a string of the event name, which is click in that case. Then the second argument, which is a callback function that will be invoked when this event is triggered. So here in this callback function, we want to display or show the window only if it's invisible, okay? Because maybe it's already visible. We don't, in this case, we don't want to show it, we want to hide it. So how do we know if it's visible or not? We can use the isVisible function from the window instance, okay? This will return true if the window is visible or false otherwise. So if it's visible, then we hide it using the hide function, okay? Otherwise, we show it using the show function. So now let's save and try now to click on the tray icon. As you can see, the window is displayed. And if we click on the tray icon again, when the window is visible, we can see that it's hidden now, all right? So that's it. That's how we create tray icons for the application in Electron using the tray class. So now it's time to build application and making it ready for production. So packaging the application and preparing the final executable that will be used by the end user, okay? So to do that, we need another external dependency called Electron-builder. Okay, so let's also install it as a development dependency, and then we have to configure Electron Builder. So to do that, we go to package.js and add another attribute, which is built, which is an object, a JSON object. In this object, we add some attributes. The first one is the app ID. So this is a unique identifier for the application. So we can use the reverse domain naming convention. So your initials, for example, or your company initials, then the application name, okay? Then the product name, which is the application name. So then we have the files attribute, which is a list of all the files to be included in the build process. So we want to include all the files in the current directory recursively. we can do that using 2 asterisk followed by forward slash then asterisk. Okay, that's it. That's all the files we want to include. Then also we want to configure the directories object. So this includes an attribute called output, which is the name of the folder of the build output. In this case, we name it dist. Okay, so a folder called dist will include the build output, and that's it. So this is the initial configuration of Electron Builder. Now we are ready to use it to build our application. But to do that, we also have to create another npm script, which is used for building the application. So let's add a new entry here, call it build, and the value of this key is the command, which is electron-builder, and that's it. So now let's go to the command line and type npm run build to run this script. And as you can see, the build process started. So I'm currently using Windows. If you are using Linux or Mac OS, you should also have the same output, okay? But the only difference is the output file extension will be different based on the operating system you're using, okay? So as you can see, there is here some errors or warnings about the repository of the project. We don't care about this, doesn't matter, okay? So if we go to the folder, the test folder in the project directory, you can see now the final output of the build process. So if I execute it, as you can see, the installation of the application starts, and finally the application will be installed and launched. I have an issue here, which is because of saving the screenshot to the same directory of the application. So if you also face this issue, if you click on the camera button and you don't see anything, then maybe you have the same issue. And in this case, I just changed the directory of the screenshots to the desktop. All right, so you can apply the same fix, all right, by going to main.js and importing OS. All right, this is a module from Node that will allow us to retrieve the path of the desktop. And here in the file path of the screenshot, you can just join os.home directory, which is the desktop directory in Windows and the home directory in Linux and Mac OS, with the file name. In this case, the screenshot will be saved to the desktop or the home directory. And I can see the screenshot, and the image is also opened by the default image opener. So everything is working as expected. But as you can see, the tray icon is set successfully, but the application icon itself is the default Electron icon. We can also configure this here in the Electron Builder configuration by adding the icon attribute and setting it to the icon path. But we don't type the extension, just the file name. And the extension should be .ico for Windows and Linux, and for Mac it's ICS. Okay, so this is something that you have to consider, that you have to add multiple icons to make your application cross-platform. Okay, so multiple extensions of the same icon file. All right, finally, we can't now close the application. All right, when we launch the application, we can either click on the tray icon to show the window, or click on it again to hide the window. But we can't actually close the application. So we should right click on this icon and see a menu that displays quit as an option to close the application. So now we are going to learn how to create a menu for the tray icon of the application. First, we need to import a class from Electron, which is a menu class. This is mainly used to create menus in Electron. Okay. Then we have to create a menu template. So this is a JSON template. It will include all the items in this menu. Okay, so it's a list of objects. Each object represents an item in the menu. So each object has an attribute called label. This is the label of this item in the menu. And then there is another attribute which is click. This is a callback function that will be invoked when the click happens on this item. So in this case, we create one object in this, which is for the quit item. Okay, so the label here is quit. And for the click event, we add a callback function, and inside it we just call the quit function from the app object. Okay, so this will quit the application. And right, so now that's it. We created the menu template, but we didn't actually create the menu, right? We created the template for the menu. So to create the menu, we have to use a function called build from template. This is a static function from the menu class. Okay, this will build the menu from that template. Okay, so we pass an argument to this function, which is a menu template, and this will return a new menu object. Okay, so we store it in this context menu constant. Then we use the function set context menu from the tray object to set the context menu of this application to that menu that we created. So we pass the context menu object as an argument here, and that's it. So now if we save the application and we build it, and then we run the application, as you can see, when we right click on the icon, now we see the context menu with the item that we included in the menu, which is quit. We click on it, now the application is closed. If you are interested in mastering Electron and learning more details about it, feel free to check out my complete Electron course on Udemy. There is a discount link in the description of the video. And if you found this course useful, please hit that like button and subscribe for similar content in the future. I wish you all the best, thanks for watching, and see you in the next video.